Assalamu alaikum warahmatullahi wabarakatuh. Bismillah wa salatu wa salam ala Rasulullah sallallahu alayhi wa sallam. Hello guys, how are you? I hope that you are all good. And welcome to these episodes for the revision of the syllabus. So we're gonna start a series of small revisions for the syllabus and we will go through these revisions totally in English. I hope this is good with you as we finished the syllabus already. So I guess that will be very easy for you to understand and to keep up with me. Each video is containing the revision for 2 lessons. So we will take it 2 by 2 until finishing the syllabus. And today we're gonna start with the first 2 lessons in Unit 1, which are measuring tools and matter state and its changes. And without further ado, let's start. Okay, starting with the first lesson, which is measuring tools. And we know that there is 3 main definitions in this lesson and we want to understand them really good at first. The first definition is the mass. The mass, we know that it is the amount of matter in an object. So what does that mean? Okay, let's take a look at this chair. This chair is made out of wood. So the amount of wood in this chair is the mass of the chair. Again, the amount of the wood in this chair is the mass of the chair. So the mass is the amount of matter, the matter that create the object. And this object, for example, which is the chair, it is made out of the wood. So the amount of matter, the matter here is the wood. The amount of the wood in this chair is the mass of the chair. Let's take another example, which is the iron, this iron table. This iron table is made out of iron, of course. So the amount of iron in this table is the mass of the table. And if we want to measure the mass of something, like these fruits, for example, we measure it by a standard mass. So these 2 masses are equal because they are balanced. Now go through the second definition, which is the volume. We know that the volume is the place that is occupied by the matter. We want to understand this definition. I don't want you to just memorize the definition, but at first we want to understand the definition, then we can memorize it. And remember something that is very important. Memorization is a bad behavior, but understanding is the aim of science. So we want to understand at first, then memorize. So what is the volume? Let's go to another place to explain what is the volume really. We have here 3 different objects, the car and this rock and this cube. If we move the car from its place like this, we will notice that the car leave a space. The car was taking a space. This space that was taken by the car is the volume of the car. So the volume of the car is the space that is occupied by this car. And taking the second example, which is about this rock, if we move this rock from its place like this, we will notice that the same as the car, the rock was taking a place, was occupying a place. This place that was occupied by the rock is the volume of the rock. And if we try to move it again like that, we will find again that this rock take a space, occupied a space, another space. This space exactly as this space that was occupied by the rock. So this space that was occupying by the rock is the volume of the rock. Going through the third example, if we move this cube from its place, we will find that this cube was taking a place, was occupying a place. This place that was occupying by the cube is the volume of the cube. So returning back again to our slide, we say that the volume is the place that is occupied by the matter. I hope that was very clear. But I want you to note something very important. I've given this question before, so focus on this point. We say that 1 kilogram of iron is equal the mass, okay, is equal the mass of 1 kilogram of water. Why? Because we talk about the mass. The mass is always equal if we talk about the same quantity. If we talk about 2 kilograms of iron, this will of course be equal to 2 kilograms of water again. And if it is 5 kilograms, then it will be equal to the mass of 5 kilograms of water. But what will be different? The difference here is in the volume. So 1 kilogram of iron is not equal to the volume of 1 kilogram of water. Why? Because we say that the volume is the space that is occupied by the object. So if we consider that the space that will be occupied by the water, this of course will be larger than the space that will be occupied by the iron if they are in the same quantity. So for example, if we put 1 kilogram of water in some specific cylinder, this water will take a specific place in the cylinder, a white cylinder. But the same quantity of iron, 1 kilograms of iron too, this 1 kilogram of iron will not take the same place that was taken by the water. So the volume will be changed, but what will be equal is the mass. The mass of 1 kilogram of iron will be equal to the mass of 1 kilogram of water, but they are different in the volume. So this is very important note to take care of. Moving to another point, which is because equal volume of different materials have different masses, this point is totally the opposite of this point right here. Because if we take some cube of wood and the same cube, the same shape of the cube of iron, they are equal in the volume, but their masses will be different because iron is heavier than the wood, of course, so that we conclude equal volumes of different materials will be having a different masses, and this is totally the opposite of this point as we referred. And moving to the third definition, which is the matter, and we say that the matter is everything that has mass and volume. For example, this chair is a matter. Why? Because it has mass, which is the amount of wood in this chair, and the volume, that is the space that is occupied by this chair. So it has mass and volume, and we conclude that it is a matter. And all of the objects around us, of course, is a matter because they have mass and volume. So when we get a question, give reason why the car is a matter, we say that the car is a matter because it has mass and volume. Moving to the next point, which is measuring tools and units for length, mass and volume. We know that there is measuring tools and measuring units for each length, mass and volume. And we all of us know that, for example, for the lens, the measuring tools are ruler and graduated tab. And according to the measuring units for the lens are centimeters, meters, and kilometers. And of course, for the mass and the volume, there is measuring tools and measuring units. And if you want to give a quick revision, just pause the video and then continue. Okay, moving to the next part, which is measuring the volume of regular and irregular solid bodies, and we will start first with measuring the volume of the regular solid bodies. And of course, we have two measuring tools for measuring the volume of the solid bodies, which is the ruler and the graduated cylinder. And in this case, we will use, of course, the ruler by this method that we will see right now. We want to measure the volume of this cube right here, and we know that the law is the volume equal the length times the width times the height, and we will measure each one of them by the ruler in this way and substitute the values into their places like this way, and at the end we will multiply them by each other and we will have the value at the end, which is 125 cubic centimeters. That's by assuming each one of them was 5. Then the law is that volume will equal to length times width times the height, and this is the true law, and the only right law is that volume equal length times width times height. Okay, now moving to the second volume measuring, which is the measuring the volume for irregular solid bodies. Let's take a look at this video and understand how could we measure the volume for irregular solid body by pouring some water in the cylinder and record the first reading, the initial reading before we put the rock, which is 100 milliliters, and recording the final reading after putting the rock, okay, which is 120 milliliters. And the volume, of course, will be the second reading, which is 120 milliliters minus 100 milliliters, which is the first or the initial reading, and the answer will be 20 milliliters or 20 cubic milliliters. So the volume of the irregular solid bodies, we can find it by using the graduated cylinder in this manner. Let's take a look at another example, which is this rock right here. We know that this rock is irregular solid body, so we can't use the ruler to measure its volume, okay? So we will use the graduated cylinder, and this will be by filling it with some water and record this level before putting the stone, and after putting the stone, the level of the water will rise up. And after recording these two readings, we will notice that the displacement that the water made is the volume of this rock. And we can get this volume of this part by subtracting the second reading from the first reading, and we will get 25 milliliters. Okay? So the volume of the stone is equal to the volume of the raised water, the part that the water rised up in, okay, after we putting the stone, of course, like in this picture right here. In this part is the part that the water is raised up in, so this part will be the volume of the stone. Moving to another point, which is measuring the volume of irregular solid bodies by using a cylinder, but this cylinder is filled completely with water. So in this case, like we see here in this picture, after we put the stone, some of the water spilled out of the cylinder. So in this case, the volume of the stone will be equal to the volume of the spilled water. So for example, if we say that the volume of the spilled water is 5 milliliters, then the volume of the stone will be the same volume of the spilled water, which is 5 milliliters, or of course 5 cubic centimeters. Now we want to take some small notes in this lesson, which is that 1 kilogram will be equal to 1000 grams, and 1 ton will be equal to 1000 kilograms. 1 meter is equal to 100 centimeter, and 1 kilometer is equal to 1000 meter. And in the same manner up there, like we will see right now, if we say that 2 kilograms, this will be equal to 2000 grams. Or if we say that 5 kilograms, this will be equal to 5000 grams. And for the tons, if we say that we have 4 tons, then this will be equal to 4000 kilograms, or 8 tons. So this 8 tons will be equal to 8000 kilograms. And in the same manner for 1 meters, then 5 meters will be equal to 500 centimeters, or 4 meters will be equal to 400 centimeters. And of course, if we say that we have 7 kilometers, then these 7 kilometers will be equal to 7000 meters, or 9 kilometers, these 9 kilometers will be equal to 9000 meters. We know that 1 milliliter is equal to 1 cubic centimeter, but is that case is the same for 1 liter and 1 cubic meter? This is wrong, because 1 liter is not equal to 1 cubic meter. 1 cubic meter is equal to 1000 liter, and 1 liter is equal to 1000 milliliter. So focus on this point and don't get lost between these two measuring units, okay? We generally use liters and milliliters for measuring the volume of liquid. This is in general. This is the most cases. And we use cubic meters or cubic centimeters for measuring the volume of solids. And now transferring to the second lesson in Unit 1, which is the matter state and its changes. So we know that the states of matter are solid state and liquid state and gaseous state, and we will discuss two important things for each one of them, which is the shape and the volume. And according to the solid state, it has definite shape and definite volume. According to the liquid state, it has indefinite shape and definite volume. But according to the gaseous state, it has indefinite shape and indefinite volume. So we conclude that the liquid state take the shape of its container. If we take a look at this picture right here and giving this example. If we pour some water in this cylinder, this cylinder will be showing that the volume of this water is 100 milliliter, for example. And if we pour this some water in another shaped cylinder, we will know that the shape of the water change, but only the shape, and the volume will remain unchanged. And in the same manner, if we pour the same quantity of water in another cylinder, the water will take the shape of its container, but the volume will remain constant. This is different for the gaseous state, because the gaseous state take the shape and the volume of its container. So the liquid state takes the shape only of its container without the volume. Now moving to the changes of matter, we know that there is solid state, liquid state, and gaseous state. For example, the solid state like the ice water, and liquid state like the liquid water, and gaseous state is the water vapor. And if we want to transfer from solid state to liquid state, this process will be melting, and melting is occurred by heating. And if we want to transfer from liquid state to gaseous state, this process is called evaporation, and this evaporation is occurred by heating also. And if we want to transfer from gaseous state to liquid state, this process is called condensation, and condensation is occurred by cooling. And if we want to transfer from liquid state to solid state, this process is called freezing, and freezing is occurred by cooling, of course. So there is two processes occurred by heating and two another processes occurred by cooling. Okay, now we want to take some important question about this lesson, and starting with the first question on decreasing temperature of water vapor at space. So concentrate on this important note. Decreasing the temperature means cooling, right? Meaning that we put the water vapor under lower temperature. So if we cooling the water vapor or cooling the gaseous state, this will result a condensation for the gaseous state, for the water vapor. So here the water vapor will condense, and this is the right answer. Moving to another example, which is the decrease in temperature is accompanied by space process. Again, decreasing in temperature means cooling. So cooling here in this picture, we have two processes by cooling that is occurred by cooling, which is freezing and condensation. So this is not melting, of course, and it is condensation, this is right, and evaporation, this is wrong, freezing, this is right. So it is not A and B, no, it is not A and C, but it will be B and D, which is condensation and freezing, and this will be the right answer. So decreasing the temperature is accompanied by, that means what will happen if we decrease the temperature. If we decrease the temperature, we have two processes, okay? And in the opposite, if we get a question about increasing in temperature, then we will know that the question is asking about these two processes, which are melting and evaporation. So in general, decreasing temperature or decrease in heat, it means cooling, and increased temperature or increase in heat means heating. This is in general. And continuing in our questions, this question says the change of water into ice is accompanied by space. So it asks about transferring from liquid state into solid state. So this occurred by cooling, and this process is called freezing. Let's take a look at the answers. It is not decreasing the volume or evaporation process. What about increasing the volume? We will leave this point at the end. D, increasing the temperature, that's wrong because it is decreasing temperature, and this is the right answer. Moving to A and B together, this is wrong, and C and E together. Well, this answer says E and C. We know that E is right, but what about C? Well, there is something important that I want you to know, that by cooling, by transferring liquid water from liquid state into solid state, which is ice, this will occur an increase in the volume. So these two answers right, and of course G is the right answer. And this point right here will transfer us to a very important question. This question says, what will happen if we put a glass bottle filled completely with water inside the freezer? So we say that water increase in the volume by cooling. If we freeze the water, the volume of the water will increase during the freezing process. Of course, the answer for this question will be that the glass bottle will explode. Why it will explode? Because the volume of the water increased during the freezing process. Let's take a look at this video right here so that we make things more clear. We will brought 2 bottles of water. This bottle is plastic, but this bottle is glass bottle, and the temperature right here is 0 degree. So it is like the freezer, as if we exactly freezing the water, and we want to note what will happen to this level of the water right here. Okay, we note that the level of the water is rising, as you see right here, right? So the level of the water continuing in rising up until it reaches a specific rate. This will make the glass bottle explode, as you see here. But why the glass bottle is explode while the plastic bottle not explode? That because the volume of the glass bottle is specified. So when the water increased in the volume, the water did not find another place to go, and its specified volume, which is the glass bottle, is not enough to its new volume, so it made the glass bottle explode. While the plastic bottle, of course, will not explode because the plastic can be extending. The last question is that the change of the matter from liquid state to solid state is accompanied by liquid state to solid state, which is the freezing process, and this freezing process is occurred by cooling. So this process right here will be accompanied by decreasing in temperature. So an increase in temperature, this is wrong. Constancy of heat, will be wrong too. A decrease in heat, an increase in the mass, this will be wrong, and the right answer will be decrease in the heat. And that's it. I hope this was good with you, and I hope this was easy for you, and see you in the next video. Goodbye.